Oh, that's right. The camera's actually over here. Hey, Spud.
What is that? Are you fixing the battery of this again?
Stop right now. Give it to Felicity. Felicity, go put it away. Where it belongs. Lock it away. Hold your hair. Put that marker away.
Daddy, you're looking at me in the screen over there.
Mm-hmm. Oh.
Oh, you got that. That's the same as your phone. Is that the second day when we went to ICO?
Okay.
I think it's your pink.
Wonder if I could do that. If I can do this, do screen mirroring here. And if I hit play, and then let's switch. What's up, Finn?
I'm exhausted. But other than that, I'm doing great. And
You're exhausted?
yeah, but I'm doing great.
That's good, I guess. I mean, not being exhausted, but
Give me a second. I'm gonna take care of these curtains.
right. Huh. Trying to figure out what's better, if this would be a better way to do it.
What do you mean? Like having the meeting, the slides on a screen while you use your phone or whatever?
Yeah, I'm using my phone to project to the TV the slides, but the problem is that the camera is, I have to have it kind of an odd position in order to be able to see the screen, the full screen. So, and that is a very inconvenient location for my workspace here, because basically the iPad needs to float in the middle of the place where I sit. So that's probably not going to work, but experimentation, trial and error. You just see the slide number there. See the waiting room. Admit and admit.
What does that thing run on? It seems pretty responsive and fast.
It's batteries. It's electric.
Interesting.
Should be like old kindergarten and do some show and tell. Have all my fun toys in here. That's one of the disadvantages of working from home is I have all my toys here to distract me. Morning, Claire. Sarah, I don't see your picture. I mean, if you don't want to put it on, that's fine too, but there you are. And I also don't see Mela, but I don't know.
It said her audio wasn't working before, so I think she's just having technical difficulties. Yeah, it says disconnect the audio.
Yeah, as I see that now. Oops. Davey, it said you left the meeting, but there you are.
Why are you driving it over your science book? Of all the random things to do.
Why wouldn't you?
Because I can. I'm going to guess the sound is actually pretty loud over the microphones. I'm tracking mud all over my science book because I was driving this in the mud yesterday. I mean, why have a capable off-road vehicle if you don't drive it through the mud, right?
Makes sense.
It's unstoppable. It's running over all my stuff though.
Brady, what are you doing?
Getting my dog.
Oh, yay, pup.
Everyone say hi, Gimli.
Hi, Gimli. Oh my gosh, Gimli, that's an amazing name. Congratulations, you're a good man.
Is that Lord of the Rings?
Yeah.
My dog is named Chops.
Your
That's a
dog
good
is
name.
what?
My dog is named Chops, like in chopsticks.
Ah, somebody got mud all over my textbook. Ah. Stop that.
I don't know who, though. It's a mystery.
I don't have a dog, but I have 5 guinea pigs.
5 guinea pigs?
Yep, I recently got 2 more.
Ding dong. Oh, I guess everybody's waiting for me to push the button on them. Admit. Oh, who's Drex? Oh,
Drex would be Sterling.
okay.
His brother's name is
Who's-
Drex, and he's probably on Drex's computer right now. Yeah. Or you're using his profile. What's up, Drex?
Forgot to sign him out.
Who would be Big Mama?
What?
Who's named a Big Mama?
I bet it's Sam. It's probably Sam.
It's not Sam.
That surprised
It's Henry.
me. Good job, Henry.
Mama and Big Daddy.
Almost didn't let you in there, Henry. The name was a little suspect.
Looking sus.
You're looking very sus today, Henry. Maybe that's why your name was wrong. You look like you're ready to go like rob a bank or something.
Oh, he needs to have something like this.
He's gonna come back with a ski mask.
He
Mr.
better.
Sears is about to flex his robbery skills on all of us.
He's about to flex his breaking and entering skills.
Possibly.
What do you think he's gonna grab?
Ski mask and a crowbar.
He's gonna grab
A
a
gun.
child.
He's gonna grab a gun.
He's gonna grab a kid.
You know what? Finn's right. He's gonna grab a kid because He has a lot of
He has
them.
a lot of those.
No, he's grabbing an air horn.
Oh no, that would be terrible.
That he should get one to get us to shut up.
Do you have any idea how painful that would be? It would probably break
Actually,
his mind.
Oh, destroy our
It
ear
would've-
holes.
It would affect him more than it would affect us. But still.
It would. He's watching. He's peeping. He's like,
Oh,
oh
God. Uh-oh.
Is that a
Is
squirt
he
gun combined with a
holding two
rifle gun?
guns and one?
He has an
did
air
come
horn!
back.
He has
He
an air
did come
horn!
back.
Oh,
Let's
no.
go!
Actually, I was just listening to y'all and kind of checking off the list of what you were suggesting.
Wearing a ski mask.
And I got a gun. And a Nerf gun thingy too.
Oh,
Nerf
it's
rival.
horrible.
I think we can all agree that Mr. Sears is officially the best teacher because he just brought in a ski mask with a bunch of weaponry to class. So, good job. You've earned this title.
Weaponry. Well, I'll be glad I didn't get out any real ones.
You should
I mean, I
bring
guess those are real.
Why
You
didn't you
should
bring
teach
those
the
to
rest of the class in the ski mask.
Notice on my mask, we got one of the best cars in the world. Ford Mustang.
Sterling,
case you
look at
didn't-
Sam.
You can play at this game.
Wait, what's
Sam's a ninja.
Sam
Uh-oh.
asks me why.
He's a ninja with
That's
a
a good
shotgun.
look. This is a good look. Yeah, this is
Yeah,
my.
let's all go get coronavirus face masks. Why don't we?
Actually, I have this just because I go shop. This is my Sam's Club mask. So if I go to Sam's Club to pick up some supplies for the fam, then I have a mask so I can comply with CDC requests.
There you go.
Lots of people
Not
at the
because I'm-
stores don't follow the requests.
Oh yeah, well, you just say most.
Yeah.
No, I would not agree with that because I was at the store last Friday and probably about 80% had masks. It looks really funny. I mean, it's kind of funny to go walk around and you see all these people in masks. And some of them are pretty creative in what they come up with for masks. So we made these so we can go out and be out in the community and not affect people. Actually,
I went to a Walmart and no one was wearing any form of protection. I'm just like, I was the only one there with a face mask. Me and my dad. I'm just like,
That's because
I wish my
masks
parents
don't
would let
do
me go to
anything.
Walmart.
the people
What?
at Walmart.
people of
I wish
Walmart.
my parents would let me go to a Walmart with them. I haven't left the house. It's so boring.
Yep,
Right.
my kids are the same way. They went for a walk with us in the neighborhood, and that's the farthest they've been away from the house since about March 17th. So they've been sequestered here for almost a complete month. So yeah, we're all feeling it. And actually, I have been home other than a couple of trips to Sam's Club. I have been home since the 26th of, or 27th. The first day we did our video meeting here, I have actually not really left the house either. So yeah, that's weird things. Not sure what to think about it. Somebody was saying something, I heard somebody say something about the masks don't work. And, you know, arguably the homemade masks are less effective, but they do at least, I think they help. Obviously they're not the best thing, but they're better than nothing. And to me, actually, my company, they said, because my offices are still open, but I have just been working from home. My offices, my company president sent an email saying that they want everybody to be wearing masks in the public or open spaces in the office. And he says the way he described it, which what I thought was pretty good, is he said, this is just about, it's about telling other people that you care. It's like, because you could possibly be, now you guys, since you've been all at home for all this time, likely is not, you're not a carrier, but you could be an asymptomatic carrier of this virus. I very well could be. And, you know, you just do things like that because you care about your fellow man. It's just, it's the right thing to do. So, well, all right, well, let's get started. I don't know. We're missing.
We have everyone. According to my calculations, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11,
You could just
12,
check
13.
and see how many people are in the
There are
call.
15 people.
I know, but if I count physically, then I can count it as calculations. Logic.
Good point.
Calculations are done in your head, not out loud.
Yep, I think we're all here. So let's just get started. All right, so does anybody else want to open us up in prayer? Anybody?
I can.
Okay. Okay. Thanks, Cedar. Do it.
All right. Dear God, thank you for this time at home, just to put our families closer together, and so we can learn about each other and to get closer to each other. And I pray that you will help us to learn from this time, just to stay clean and to keep other people and to be considerate about other people, and just to love our families more, and to be able to be around them, and to be able to be kind to our families and to other people. In Jesus' name I pray. Amen.
Amen. All right. So let's talk. I'm gonna try something a little bit different for a few minutes, and if it just doesn't work, then we'll switch over to what we've been doing. Because when I do the slides on the screen, I can't see really anybody. I can only see like 2 or 3 of you. So I'm gonna do something a little different, and we'll see how it works.
Get another device tuned in on the meeting. That way you can have one device for the slide and the other device to see your students.
That's kind of the idea. Actually need, because my screen will only show 9 pictures. So I have to kind of flip back and forth between the 2 different screens. And so I can't actually see if y'all are sleeping and stuff, which, you know, you're at home and all comfortable, right? So you probably take a little nap during class. No, nobody would ever do that.
I got this big light in my face. That would be very difficult.
And all that toilet paper behind you. You could actually pile that up and
We don't talk about that.
make a nice little comfy bed there. Okay, let's talk about light. So we're finished with module 14, moving on to module 15. And then actually, before I do that, before I jump right in talking about sciencey stuff, I want to see if anybody has any questions about or concerns about stuff, the
Yeah, did
homework.
were we able to finish module 14? Because I don't think we covered everything. And
If you took the
in the
test, then
class.
you should be done with the module.
Well, we
I
may
don't
not
think
cover.
we finished it, though.
We may not cover everything in class every time, just for the sake of time. Let me look real quick and see if I had anything. No, we covered all the slides. We did get through all of that, but we obviously don't have time to cover every single little bit of information in the module. So that may be why you're feeling like we didn't, but we did get to the end of all of my slides, all of my notes that I had on it. So some of the things that we just kind of pass over because I try to concentrate on the more complex conversation topics. Oh yeah, we did not talk about the ultrasonic waves and things like that using sonograms, but y'all are
I don't
y'all
think we
probably
talked
familiar
about
with
the
that.
decibels and bells either.
That's true, we did not. We were we covered the amplitude conversation, but we really didn't talk about decibels. So that's what we did not get to. And sound volume in that sense. We just ran out of time.
Also, Dropbox is not currently letting me upload my files, so I'll get my dad to look at that today, but that I may not be able to get my stuff in today if we can't get it to work.
Okay. Yeah, is anybody else having a problem with getting your files uploaded?
I'm not sure.
I didn't see a bunch of them, so I think a lot of people haven't uploaded today.
Yeah, I was actually wondering about that. I usually upload all my stuff on Wednesday night, but just knowing that I guess the way that we usually would do it, would we do it on Thursday right before class when we turn in our work? So is there a specific time you want us to turn in our work, or should we just do it like right when we get it done, or right before class, or the day before class, or
You can turn it in anytime during the week. You finish an assignment, you want to just go ahead and submit it, go ahead, do that. Technically what we're saying is the deadline is Thursday. So I would say that if you get it in the Dropbox sometime between, well, I would say by midnight on Thursday, or you could probably actually stretch that a little bit. And if you're putting stuff in the folder at 2 and 3 in the morning, which you really shouldn't be doing that because you should be sleeping, then at 2 or 3 in the morning on Friday, I don't think we're going to count you late for that. But if you can't figure out if it's not letting you in, I mean, I have limited capacity. I have limited, not unlimited, I have limited capacity in my Dropbox folder. So I may not, if it gets maxed out, then we may not be able to, I may have to clean some stuff out in order to do the files. And actually everybody's putting lots of stuff and lots of megabytes in there, but I don't think we'll hit the limit. I'll double check that and see how much I've used, because I didn't have really much of anything in there. I don't use that Dropbox folder very much. But anyway, I'll double check that and make sure that's not an issue on my end. But if you can't get your files uploaded, please let me know. Preferably, like I said before, text me. or give me a call on the phone, and that way I'll be sure to know about it, because the emails, if you send me an email, I've noticed actually a couple of people have sent me emails on like Wednesdays or something like that, and then I get a whole bunch of Dropbox emails, and I'm skimming through my emails trying to keep track of all of it, but it's because of all the myriad of Dropbox emails, I've noticed that I've actually missed a couple of them. So it's not intentional by any means, but it does happen. So
Do we have any news
anyway,
concerning the quarterly?
So
yet?
what?
Is there anything?
Do I have any new?
Yeah, like, do you know when we're going to get it, or if you're finished or something? And
I'm still working my way through those, and it's just everything with the online environment, because I'm still trying to adapt to it. Everything takes a bit more time, and honestly, it's just not. Haven't been getting to it, so I'm gonna try to have them by this weekend. So you'll see them come in your email Sunday, or on, because I think we're going to have another rainy weekend, so I'll try to get them done this weekend. Last weekend I was kind of sick a little bit, so I just didn't feel up to doing much of anything. So it wasn't coronavirus, don't worry. It's nothing like that. It's just something else. No idea what, but
I think you can
anyway.
see that. But it just says uploading at 0%, and it sat there for like 20 minutes without doing anything. So
Okay.
I'll see if I can get my dad to look at that today, and I'll let you know if I get it working.
All right. Okay, any other questions? Okay, well, let's talk about, let me see, you guys got to tell me right away if you can actually see this. It's because I'm going to do, it's backwards to me. So there is.
I can see it.
Can you read it?
Yeah, it's
Is it
good.
clear?
It's not
Yep.
backwards.
it's good.
It's good.
Okay, and then I get to do this.
It doesn't have to be backwards for you. You can mirror your screen so that it's only backwards for us. But if it's only backwards for us, it'll be right. I don't know if that makes sense because the camera.
No,
has to be
it's mirrored for me, and that's intentional. Your computer sets it that way on purpose. Your selfie cameras and whatnot, they're all mirrored because you're used to looking at yourself in the mirror and moving. And if you actually reverse it, make it where it's actually showing the picture correctly, then you go to move your right arm and end up moving your left because everything is reversed to what you're used to. So there may be a day when that doesn't happen. So anyway, we're talking about light, and actually the concept of light is something that actually is very, very significant in our world. In fact, I would go so far as to say that without light, life on this planet would not exist, because it is a fundamental component of many, many things, with some of which we've already talked about, and we're going to talk about it a little bit more. But let's actually look at it from a little bit different perspective. Before we talk about it in a scientific sense, let's think about light in a more of a spiritual sense. So I have here for you, can you read that? It's kind of blurry looking. It's what?
I can read it.
It's kind of blurry on my screen. Where does light come from? So who can answer that question? Claire?
God.
That is correct. God is the source of light. In fact, actually, there's even more specific verses, but let's look at a couple of them here. In Genesis chapter 1, verse 4, and I bet you can't read that. Okay, let's this is let me go
You
ahead.
could just tell us
and
what it says.
Let me switch over to switch over to the other way because I want y'all to see this. It'll only take a second. Okay, where does light come from? Genesis chapter 1, verse 4. I bet you can read that now, right?
Yeah, I can read it.
So this is, as you probably know, or you should know, Genesis 1 is all about when God made the world. Verses, actually, this I have Genesis 1, verses 3 and 4 listed here. And God said, "Let there be light." And there was light. God saw the light was good. God separated the light from the darkness. Now, what that's talking about is visible light. And we're going to talk about a lot more than just visible light, because he made light that's much, much more powerful. Here's another reference for you here. 1 John chapter 1, verses 5 through 7. 5 through 7? Wow, I don't see 5 through 7 on there. I just see verse 5. So let me see what 5 through 7 is. First John chapter 5, and I use the English Standard Version in case you're wondering if it's a little bit different wording. This is the message we've heard from him proclaimed to you, that God is light, and in him is no darkness at all. Now, of course, the light he's talking about there is also the light that represents good. So good versus evil. It says, verse 6, that's verse 5. Verse 6 says, "If we say we have fellowship with him while we walk in the darkness, we lie and do not practice the truth. But if we walk in the light as he is in the light, we have fellowship with one another, and the blood of Jesus, his son, cleanses us from all sin." So talking about the righteous light. It goes on to say things like, if we say we have no sin, we deceive ourselves and the truth is not in us. Boy, we could actually make a whole sermon on that but that's not science lesson so we want to keep on moving. Revelation 21, verses 22 through 25. "And I saw no temple in the city, for its temple is the Lord God, the Almighty, and the Lamb. The city has no need of sun or moon to shine on it, for the glory of God gives it light, and its lamp is the Lamb. By its light will the nations walk, and the kings of the earth will bring their glory into it. And its gates will never be shut by day, and there will be no night there." So you'll learn to sleep with the light on, or you won't sleep. How about that? I like that idea. I could do with the extra time.
That's because
But my body says, yeah, good idea, but that doesn't work either. Short term, maybe. Long term, you can trick your body for a certain amount of time, but at some point, reality kicks in. You have to go to sleep.
You're right. Red Bull would work, though.
Never tried any of that. I'm not sure I want to.
I'm not allowed to drink that either.
Darkness, Cedar. Red Bull it is.
After about 3 cups of coffee, I start getting real jittery. My hands will shake. So I think Red
Stay
Bull.
away for days with no side effects.
Is that
Meet the Robinsons.
Yeah. The freaking coffee injector sticker.
I was thinking that might be Over the Hedge. No, that was Hammy from Over the Hedge. They give him the energy drink. The squirrel.
Haven't seen Over the Hedge in years.
Okay. So this is kind of this format doesn't give me the opportunity to ask questions. So we're just gonna walk through it, which I guess that's probably good because I mean, it'll reduce the amount of time it takes to go through some of these things. But what is light? And well, it's not as simple as saying brightness or darkness displacement. There's a part of it that is for sure what gives us the daylight. It's the brightness of the sun or the light that comes from a flashlight, or when you turn on the switch on the wall. Those things definitely are produce light, but looking at it in a smaller scale, the scientist Christian Huygens did experiments that demonstrated that light acts like a wave. Things like if you take a piece of paper and cut a narrow slit in the paper, you can, and then shine a light, say a black piece of paper, shine a light in there at the paper, and then look on the back side of it, and you will see that the light actually creates it'll fan out through the slit in the paper. So the light, even though it's going through a narrow passage, actually it will spread out on the other side, and that's characteristic of a wave-like behavior. And then, of course, the brilliant Sir Isaac Newton determined that light, well, it behaves like a particle. I'm going to keep using that word. It behaves like a particle, and then, of course, it also behaves like a wave. So, it's kind of those guys in those days, they were probably thinking, well, which way is it? Is it a particle or is it a wave? Well, and the actual answer is that it actually is both. And I'm sure that the Sir Isaac Newton and Christian Huygens would be like today saying mind blown if they knew. I'm not sure, they may have learned these things. I don't think quantum mechanics was determined or learned by the time of Newton and Christian Huygens passing, but in any case, James Clerk Maxwell came along. You remember James Clerk Maxwell? He actually developed something like 40 equations to describe the electromagnetic force. So electricity and magnetism was his specialty. Well, and if you recall, what is the particle that is exchanged in the electromagnetic force?
Photons.
It is photons. What are photons again?
Tiny packages of light that act like particles.
Exactly. They're packets of light that acts like a particle. So, so James Clerk Maxwell's specialty again was electricity and magnetism. So he learned many things about that, developed the mathematics behind it, and was able to explain many things about electricity and magnetism. And he was the one that actually determined that these little packets of light, so it's little segmented pieces of light that oscillate back and forth. But they oscillate back and forth, so I'm going to oscillate here in the horizontal, but they also oscillate in the vertical plane. If you could picture the packet traveling towards the camera here, so you have the oscillation in the vertical and the horizontal plane. So at 90 degrees to each other, you have a wave oscillating. So that's on your page 368 in your book. That's the picture you're looking at. To me, it looks like a bunch of guitar picks because it's similarly shaped to a guitar pick. That is really good. So I happen to have a couple of those. Don't worry, I didn't bring my guitar to class, but I have a guitar pick, so it looks kind of like a guitar pick in this picture here. But what that actually is it's showing you at an oblique angle. It's showing you an oscillation going in this direction and an oscillation going in this direction. So if you were actually to turn that picture this way, then you would actually see something more like this. So you have the oscillation here, and you turn it and look at it. So if you look along the end of that arrow, then you would see that you're going to see everything looks like a plus sign. The electric oscillation and the magnetic field oscillation. So that was James Clerk Maxwell. He's the one that figured that out. And again, as I've said many times in this class before, thankfully, y'all don't have to actually understand the details behind that, because it would be quite complicated, I'm sure. The mathematics of that, the mathematics of wave theories are not really that easy. It's not the easiest math. It's not too difficult, but it's definitely not the easiest. All right, so I think that's really all we really need to talk about in terms of the theoretical nature of light. But let me just draw out a couple of key ideas here that we've talked about so far. So one thing, and this is to me the hardest part of everything to understand of everything we've talked about to this point, is just that what the Bible says about it. God is light. And so we don't really understand that, but we know that according to the scriptures, he is the source of light. And I think that is in both physical and spiritual context. Obviously the spiritual context, but I think that also implies that he is the source of light in the physical context. And before we talk about the aspects of light, like speed of light and so forth, I think we need to just take a moment and consider a few things about light that actually are going to become more clear as we discuss things in this module as you get farther into it. But since God is the source of light, and then the second thing is that light is a complex and yet essential element of life, because if we start thinking about the impacts of the electromagnetic force on everything, you can take if you took that away, the electromagnetic force works because of light. But if you take that away, then everything ceases to exist, because that particle exchange that affects the electromagnetic force holds the atoms together. It holds not the nucleus of the atom, but it is what holds the electron shells on the atom. It is what causes many chemical bonds. And if you disassemble that, if you take apart the glue that holds together the chemical bonds, if you take apart the glue that holds together the electrons in the oh, Sarah, did you fall out?
Our strawberry's back.
Sorry, my computer crashed and won't let me log back on, so I had to hop on my phone.
Oh, okay, well, your computer still shows you on. I see the strawberry, and I see you're still on there.
Well, I don't know. The computer won't turn on again, so don't know what's up with that. But
you could probably whack it with a sledgehammer. I think that usually fixes it.
I think my dad would get a little upset if I did that.
Check the battery on the back. Maybe the latch came unlatched somehow and it's loose.
No, it's still on. Like everybody else can log in, but I can't. It won't let me log in.
I see. So
Wait,
it's
it
not
did-
the computer's not dead. It's just not letting you access it.
right.
Did you
But
try
I mean-
restarting it?
Yes, I did.
Oh, now it says. Now I think it says you left.
Okay. Well, I'm here and I can finish class. So
Okay. All right. So I was just basically saying that if we did not have light, then our world would cease to exist. Okay. And we're gonna see that light is actually a little bit more involved as we get farther into it. Okay, so let's break from theoretical and spiritual conversations, which are fun in their own right, but we'll just keep on moving. All right, let's talk about the speed of light. Now, we already mentioned this in our conversation last week because we were talking about the speed of sound. And in the speed of sound, remember, is dependent upon air temperature. But I also said that when you do that experiment of the hitting rocks together at one end of the street and trying to listen to the difference in time, the reason that works is because the speed of light is dramatically faster than the speed of sound. So you can see the rocks hit a significant amount of time sooner than you can hear them. So because speed of light is extremely fast. In fact, we actually have talked about the speed of light before in this. I think we have. Yes, we talked about nuclear reactions and the equation E equals mc squared. So we've already kind of seen some of the speed of light, but it's needless to say, it is the fastest that anything, or the fastest of anything that travels anywhere in the universe, so far as we know. There's nothing that can travel faster than the speed of light. So that is, you can see if you look at your books on page 369, there's a table here that tells different light speeds. Hey, I see that yawning, Claire. Okay, shows different things. So it shows the speed of light in air at 25 degrees Celsius. So it specifies the temperature there because the speed of light is somewhat sensitive to temperature, somewhat dependent upon the temperature of the air. I think maybe the cooler the air, the slower it goes. That would be my guess. I don't know for sure, and I just have never looked that up. But I have a suspicion that that would be true. Now, as you can see there, in air, it travels at 300,000 meters. No, 300 million meters per second. If you want to do a quick conversion into a unit that you might actually more nearly understand, you might find that it is approximately 186,000 miles per second. I did not misspeak there. 186,000 miles every single second. So it can travel extremely fast. It says 300,000 meters per second is also equal to about 670 million miles per hour. But I think that number still is unfathomably large. But 186,000 miles per second, incidentally, let's do just a little bit of math. here, just for kicks. The circumference of the Earth is about 26,000 miles, 24,000, something like that. So let's just go 25,000. Call the average. 25,000 miles. I'm going to go 186,000 divided by 25,000 is 7.4. So 7.5, the speed of light, an object traveling at the speed of light theoretically could travel or all the way around the Earth 7.5 times in 1 second. So mind-bogglingly fast. And that's, as far as we know, that's the fastest it can travel. It travels about that same speed in a vacuum as well. That's another interesting property about light, is it actually, in contrast to sound has to have something to oscillate. That energy has to transmit through a substance. But light, on the other hand, can travel through a vacuum. So those particles, that's part of the particle function of it, is it actually can travel through a vacuum. It does not actually oscillate anything. Light is pure energy. So in the vacuum, it travels about that 300 million meters per second. Okay, then you can see there's some different deals there. Alcohol, it travels 225 million meters per second. So it's slower than it travels in air, but not by a ton. And then water, it slows down a little bit more to 220 million meters per second. And plastic, it's 189 million. And then glass is 175 to 185 million. And then diamond is one that's listed here as the slowest at 125 million meters per second. So that's actually a little bit less than half. It's about 40% the speed of light in air. Now, this relationship between the speed of light in a vacuum or in gases versus the speed of light in liquids is an important thing to understand. So here I've got on the slides that it is that light travels fastest in air or absence of air in a vacuum, and then it slows down in liquid materials, and then it slows down even more in solid materials. So you can see that. Now it's important to remember that. That actually is going to come back up later on. So these 3 points here, make sure you kind of have a grasp on that. And it's here's one way that you might actually be able to remember it. It's pretty much the opposite of speed of sound. Sound travels much faster in solids than it does in liquids, and it travels faster in liquids than it does in gases. So it's the exact reverse of that property with respect to sound, okay? So that might help you remember it. Keep on moving. All right, so let's talk about wavelengths and frequency of light. Now, you actually had an experiment that I believe you were supposed to do on this one. Did y'all do an experiment having to do with splitting light into its spectrum? Something, experiment 15.1. Did I assign that one? No? Which one did I assign?
You assigned 14.5 this week.
Oh, so you just haven't done it yet. Okay, so it'll probably be assigned next week then, at some point. You'll probably do an experiment 15.1 and maybe 15. Actually, all of the experiments, 15.2 and 15.3 are actually the ones, those ones are not that impressive, but 15.1, 15.4, and 15.5, even if I've not assigned them, I highly, highly recommend that you do those. You got to do 15.5. I don't remember if I assigned that one or not. I know I took a couple of experiments out for officially turning in. 15.4 is super easy. You can do that one in about 5 minutes. Even if you don't write the report, you ought to do that experiment. In 15.1, I'm hoping I assigned that one as well, because that's just, it's kind of cool. It's not anything that's going to be surprising to you. You've probably done experiments similar to it. If you've done anything with a prism, or if you've done an experiment similar to it, making a rainbow in some form or fashion. So, but let's talk about, let's see, I'm going to talk about the visible spectrum first. So you're going to do experiment 15.1 at some point. And the visible spectrum is what you will be able to see. Actually, that's all you can ever see, is the visible spectrum of light. So that is all of the light from red on the, well, it's on my left here on the page. Look at page 371 in your book. From the red, which is a 700 nanometer wavelength, all the way up to purple or violet, which is a 400 nanometer wavelength. That is the limits of the electromagnetic spectrum. Now, the colors, as it says here, it says 700 nanometers. That is, a nanometer is 1/1,000,000th of a meter. So the wavelength of red light is 700 millionths of 1 meter. No, I'm sorry, it's a billionth. So that would be 700 billionths. Trying to convert that into, it's like let's not do that on the fly, because I will get the numbers wrong. Suffice it to say that it's actually a very, very short distance. A millimeter is 1,000th, a micrometer is 1,000,000th, and a nanometer is a billionth. So it's, if you divide a meter into 1,000,000,000 segments, so there are 1,000,000 nanometers in 1 millimeter. So wrap your head around that. So now this is 700 nanometers. So it's a really, 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 really short length. And then we go all the way up to 400 nanometers. So that's actually even shorter. But it's the range of visible light is all of 300 nanometers wide. So, and that's the wavelength. So you remember the wavelength, just like the properties of sound, the wavelength is the distance from crest to crest. So this distance from here to here is the wavelength of the wave. And that's what it's saying is between 400 and, whoa, that was ugly, and 700 nanometers, little n m. Okay. That's so ugly, I'm going to just erase it right now. Okay, so that is the amount of the visible spectrum in the electromagnetic spectrum. Now, you probably already read that the electromagnetic spectrum is much, much wider than that. So if you look to the next page, 372, it actually shows you this little picture here. And you can see there's the visible spectrum right there. And it is just a small fraction of the overall electromagnetic spectrum. And here's where this gets interesting, because all of these, this is all the range of known wavelengths of electromagnetic, what shall we say, energy. We'll just call it energy. And it is used for many things. So you can see that we use, what do we use to warm up our hot dogs? You use light.
Radiation.
Yeah, electromagnetic rate.
That's freaky. I had microwaved hot dogs yesterday.
Dude,
So
same.
now,
I don't
Now you
own a
know.
microwave.
shine your flashlight at your hot dog to heat it up, right? So microwaves are good for warming up hot dogs or frozen pizzas. And they also are good for if you take a hard-boiled egg and microwave it for like a minute. That's a fun thing to do.
Hang on.
It'll explode.
You put
man.
your frozen pizza in your microwave?
That's true.
The personal size ones, yeah. You've never done that?
That's utterly disgusting.
I only
Is it?
have a
Oven.
toaster oven.
Those
Where's-
go in the oven.
Pizza
I have
goes
a-
in the oven.
I have a toaster
Pizza
oven.
rolls going.
I have a small oven
I
Well,
have,
and a normal oven.
you know, sometimes you don't have access to an oven. And sometimes, you know, if you look at the time it takes to heat those little personal size pizzas that are about like that big around in the oven, it's like 45 minutes in the oven. The frozen ones.
But it tastes better.
You know, you're right there. I can't deny that, but it is certainly edible if you microwave it, and it's not disgusting. It's
Are you
just
Despite the fact that
not.
you're
convection
injecting
bake?
nuclear radiation into it.
It's
Good
Microwave is
morning.
bad for you.
The Mythical Morning
nuclear,
tested it.
Yeah. It has
nuclear
energy.
radiation.
Yeah.
Nu-
It's just minimal amounts.
it is not nuclear radiation. It
Man,
is-
what are you talking about?
Do you know the design of a microwave? Look up
It
the
is.
design
Yeah,
of a microwave.
buttons and a door handle on it. And there's a little spinning tray inside.
The nuclear buttons, Sterling. Nuclear buttons. What the heck, buttons?
any
That's all I
case,
can
it
think of.
is
And
it is electromagnetic radiation. It is not nuclear radiation.
There's
Nuclear
minimal
radiation
amounts.
is a different. Nuclear radiation is a completely different thing.
It's been tested.
Ben's building a rocket from a microwave.
Yes.
Yeah, and
I stand firm.
I've been eating food that's been microwaved pretty much all my life, as have you, and we're not dead yet. So
Look,
I
Okay, the
say,
assumption that all nuclear radiation will kill you is false. It's just such minimal amounts that it can only, like, you know, warm up food. I mean,
yeah.
it's not the only radiation, but it's in there.
Anyway, yeah, let's keep talking about the electromagnetic spectrum. I didn't realize that mentioning a microwave was going to be such a hot button issue, but obviously, touch some nerves. It's just an appliance, and you can use it or not use it, and it's not spiritual, and there's not a right or wrong here. This is amoral. This is not a moral conversation.
There is a wrong. Pizza goes in the oven.
Yeah, chill out. You put yours in the oven, and I will actually spend my time learning other things, and we're all gonna die in the end anyway. So yeah, just hopefully not right now. And
play
it's
that
not
game.
gonna be the microwave food that causes it either. It's your days are numbered according to the scriptures, and so whether it's by automobile crash or coronavirus or cancer or heart disease, you know, none of us get a pass.
Or
So-
putting pizza
Or
in the
natural
microwave.
causes.
or what? What did
Natural
Sarah say?
causes, old age. We don't have to
Natural-
die some horrible way to die.
Yeah.
Thank you, Sarah.
That's the other option. I mean, there's
That's
many,
the boring option.
many ways to go. So, but the fact of the matter is when God says you go, and that's it. You know, so, and the means and methods are, well, they are what they are. You deal with it. All right, so let's keep talking about electromagnetic spectrum. Boy, that really conversation really went weird. Anyway, so the other things that you get from electromagnetic energy is this thing, your favorite thing in the whole wide world, the little thing
I don't
that you
have
take to
one.
bed and
We don't.
We're homeschoolers. We
This
don't
is
have
my favorite
phones.
thing in the world.
I have a phone.
Okay, so your contemporaries, your the kids, the public schoolers. Did I say that? No, there many young people, I guess including myself, use these little smartphones, and you know what? They rely heavily on this concept of electromagnetic energy to function. It has a multi-band radio, multiple uses of radio waves. So things like near field communications, Bluetooth, just being able to talk on the phone, Wi-Fi, which how many of you are running Wi-Fi right now to connect to this video call?
Wi-Fi.
I am literally running Wi-Fi through a cord.
Wi-Fi.
Well, that's not Wi-Fi then, Henry.
How can you run
It's,
Wi-Fi
it's
to a
just a network cable, so technically it
It's
is.
So it's Wi-Fi.
But let's not get
cable.
into the whole microwave argument again.
No,
Okay,
it's
that's factual. That's
Good
not
call.
an argument. That is factual. Look it up.
microwaves off the topic for today, the rest of the day. Nobody can even say that word. That's now going to become the
M word.
the M word for the day.
It's grounded.
That's right. So anyway, so you're likely using wireless communications to make this phone call. I use Wi-Fi all day, every day on my work computer while I'm working from home. When I'm at the office, I'm connected through cable, so there's no Wi-Fi involved in that, but it does use a wireless mouse. So, you know, many different applications. Every single one of those depend on light to work. And that's not visible spectrum light. So you don't see that light. Obviously, when you turn on your Wi-Fi, there's no glow other than the little light that's on there to tell you that the device is on. When you turn on your Wi-Fi, there's no glow that emanates from that device, but there is electromagnetic energy that is being transmitted, and you do it in waves and pulses in such a fashion that you can actually transmit data in the form of, in binary form, which is in ones and zeros, over the air and connect it to your computer device, which then sends the signal round trip. It's highly useful technology. We've actually learned, mankind has learned how to take the understanding of electromagnetic energy. Okay, who's doing that?
Sam, we can hear you. We can hear you humming. That was hilarious.
Mr. C.
I just muted everybody. Global muting. Okay. So many uses of electromagnetic energy, things like radio. Also, if you ever tune into like Way FM or what's the other one? The one with the Wally show. That's way FM. Air One. Air One is the other one that we listen to. And then there's other radio stations. Most of them I don't ever listen to because they have too many commercials. KLTY. I'm looking at you. Okay. You can also receive television. Nobody ever does that anymore, really. Some of you may still have your rabbit ears. I actually do. I use rabbit ears. I don't have a subscription TV service because it's not worth my time. And then, so that's basically below the visible spectrum. So radio, infrared. Incidentally, most of the heat that we receive in our planet is from infrared radiation from the sun. And this electromagnetic radiation we're talking about, which is different than nuclear radiation. Infrared is just below the visible spectrum, and then I said the primary means of heat transfer in the universe. So when you turn on your stove, or if you have an electric stove or gas stove actually, and you see the orange fire, that red light is a form of, or the reddish color of the flame is partly because it's close to the infrared light, but a lot of the heat is transferred to the food or whatever it is you're cooking by that the infrared. Your oven coils turn red. Okay, keep talking here. Then we get to the visible spectrum, which we've already kind of briefly talked about. So that's your colored light, and then you have your little way to remember that, Roy J. Biv: red, orange, yellow, green, blue, indigo, and violet. Red is the longest wavelength and has the least energy, and violet is the shortest wavelength and has the highest energy. So anybody have a question about that? Finn does.
That was
Okay.
me saying, nope.
All
I
right.
just can't think about Sam just going,
Okay, do y'all know what the Flintstones?
Yeah.
The
It's
Flintstones?
the Flintstones.
Do you know the difference between Dubai and Abu Dhabi?
Yes.
Abu Dhabi.
You do?
They're different colored hair.
Huh?
This is worse than the M word.
The difference between, do you want to know the difference between Dubai and Abu Dhabi?
Their names.
Besides that,
Yes,
Their
we want to
hair.
know the difference. Get
Yeah,
out. Just tell it.
the people in Dubai don't like the Flintstones, and people in Abu Dhabi do.
I'm never forgiving you again. I'm leaving. I'm out of here.
See, if this was a microphone, I'd just do this. Mic drop. Okay.
Abu Dhabi, dude.
All right, the ultraviolet. So moving up the spectrum to shorter wavelengths, higher energy. Ultraviolet is just above the visible spectrum. And of course, I have my purple flashlight here.
I'm pretty sure that's called a black light.
It is a black light, but the black light works because it actually transmits energy, or ultraviolet, or light that is very close to ultraviolet.
Violet light. Boom. Therefore black light.
Ultraviolet. It's called black light because Well, it's a little bit of of a misnomer, I guess, because in theory, black light actually is would be one that you can't see. It's black light because it's barely visible, the light itself. But if you see a black light, it shines and it reflects off of brightly colored objects and makes them even look brighter. So like this, it works best obviously in a dark room. And that's not good enough. Let's see what else I got here. Yeah, it's not going to work. Not going to show over the camera very good.
Did he just flex nerds candy on us?
That's just what I had this colorful right here, and I wouldn't call it flexing. I mean, those things are $1 a box, so you can probably find some too. So, but you're probably familiar with the black light if you've gone to lunar bowling. At what's that place? Brunswick. Is it called Brunswick still? And there's lots of places that do it. Bowling alleys. They like to they turn off the regular lights or turn down regular lights and turn on some black lights, and then they have all your bowling pins and the balls tend to kind of look like they're glow in the dark.
Or glow in the dark mini golf.
I haven't tried that.
Oh
but that
yeah.
sounds too.
I did that once at main event.
So anyway, that's because of a black light, and they call it, like I said, they call it black light because you really can't, or it should be. If you did it actually as a real, true UV light, you wouldn't be able to see the light. That's why it's called a black light. I think, like I said, that's a bit of a misnomer because I don't think we've ever seen a true black light. At least I haven't.
A flash dark.
What?
Nice job, Cedar. Nice job.
Instead of a flashlight, you have a flash.
Yeah, we
dark.
got onto
Flash
that.
dart. Got it. I thought you said flash dart. As in like dart gun.
Oh my god, you did not just make that joke.
Yeah, from Despicable Me.
Yeah, there was this school, and for Halloween, all the teachers dressed up as minions, and the principal dressed up as Gru.
It's brilliant. Okay.
And he walked around and just stayed angry at everybody.
Okay, let's talk a little bit more about ultraviolet light. We said it's just above the visible spectrum. It's a higher energy than violet, and it is also harmful to living cells. So if I shine this purple light at myself, oh, it actually makes my computer keys glow. You can't see that though. If I shine this ultraviolet flashlight thingy that I've got here at my hand for a long time, then maybe it might actually be killing some cells. There is an amount of UV light that comes from the sun, and that's what gives you a sunburn. Or if you're prone to that, you may get a bit of a suntan, but everybody can actually get a sunburn if you stay out long enough. All right, and then be above that. UV lights, you might actually see them if you have like some people or some versions of electric toothbrushes actually have a UV light in the charging stand, and you put the toothbrush in upside down with the brush down into this thing that's got a UV light. And the reason for that is to kill any kind of living organism on the toothbrush. Also, you might see it at like a beauty salon or something. Not that I have any experience with that, but a barber shop or something like that, they'll put the combs and the brushes under a UV light, so they don't take one person's head lice and put it on the next person. I have seen that as well. So there's a couple of different places where I actually see UV lights being used. Kind of gross, but it is what it is. Okay, and then finally, we have the X-rays and gamma rays. X-rays are higher than UV rays, and we use those, obviously, to take pictures of your skeleton. Check if you have a broken bone. So many of you have had probably had an X-ray at some point in time. Oh, the dentist does it. If you go to the dentist X-ray does X-rays of your teeth to see if they if you have any holes in them that might not be visible from the outside. So the reason for that is that you can actually address any kind of issues before it becomes a toothache, which is no fun. All right. And then gamma rays. Gamma rays are generated by radioactive decay. And they have the highest energy in the electromagnetic spectrum, as far as we know. There might be something that's got higher energy, but we haven't identified it. All right. So that's the electromagnetic spectrum. Does anybody have any questions? As long as it doesn't involve that M appliance. All right. So behavior of light. Now we're going to concentrate for the rest of I think the rest of the module is pretty much covering visible light. So reflection, and this one is actually pretty simple. The law of reflection, the angle of reflection is equal to the angle of incidence. So if you shine a light at a mirror, if you have a mirror like so, and you have a flashlight pointed at the mirror, or a light source, then it strikes the mirror and bounces off. And if we were to measure the angle, now let's just draw this line here. This line is intended to represent a perpendicular line. When we're measuring angles with respect to the law of refraction and the law of reflection, we're going to be measuring the angle to the normal, which is, the normal is another word for the perpendicular, a line perpendicular to the face of the reflecting object. So this is this is the angle we measure. So we might call it a Greek letter theta. And we measure this angle and call it Greek letter beta. Because for some reason, we mathematicians like to call angles by Greek letters. So if we had the law of reflection simply states that theta equals beta. My first beta was better than that one. But you get the idea. So that's just the angle. If you measured it, if you did this very carefully, you had a good perpendicular line, and then you set a protractor on that, you would measure, and you have actually that's your experiment. So you can do this. This is super, super simple. Just get a piece of paper. If you got a mirror, then you can just measure this angle theta and measure the angle beta, and you will find that they will be very, very close to the same. The only reason they won't is because your perpendicular won't be perfect, or the mirror surface won't be perfect, and there'll be a tiny bit of angular error in that, or because you're trying to read it on a protractor and you're reading between the lines. And so there's a number of different ways that it can come up, but I suspect that if you do this carefully, you can get it where you'll find that these two numbers will be the same within a degree or so of each other. That is the law of reflection. It is, like I said, that one is really, really simple. So simple, it's almost even boring. Not really. Now, where it becomes more difficult, and look, my colors changed, my font colors changed. Where it becomes a little bit more difficult is the concept of refraction. Okay, and this is where I told you need to keep in your mind what causes light to slow down and what substances it speeds up. Because if light goes into something where it changes speed, then it actually bends differently based on whether it's speeding up as it crosses that boundary or slowing down. So, and you need to remember this part because, well, in my experience as a physical science teacher, this is one that actually gets, many people get confused. So my recommendation is that you memorize the law of refraction and which way it bends when it goes into a different substance. Okay, so let's just start with when light slows down, it bends toward the perpendicular. So let's just do a little more sketching here. So if I have I'm just going to draw a little arrow as a light source. And let's make my light beam red. So here's the beam of light coming out of the light source. And I'm going to draw a surface here as straight as I can. Actually, let's change the color again. Let's just say it is a piece of glass, which actually kind of has a greenish tint to it if you look at it on the edge. So this is a piece of glass. I'm gonna draw it nice and thick piece of glass. I'm gonna run out of room. That's okay. Mostly I'm concerned about this first piece. So my red beam of light is going to hit the surface of that glass. Now I'm going to draw with a black line, I'm going to draw the perpendicular. The perpendicular is right here. I'm going to stick it as close as I can to the point where the light hits the glass. Now, when the light enters the glass, let's switch off whiteboard. It's going to, is it going to speed up or slow down?
Slow down.
It is going to slow down. That is correct. So we're going to project the path of the light that it would normally take if it was not going to, if it doesn't hit the glass, then this is the path the light would take. So it's just basically going to follow the same line. So that would be the straight path of the light continuing on here. And this is actually really hard to do. But you kind of see it's along the same line. So the actual path of the line is going to bend which way?
Toward the perpendicular.
Toward the perpendicular. So let me draw this a little bit different real quick. This will only take a second. So here is my glass. Okay. Now I'm going to draw come on. Here is my perpendicular line again. Ugh, that did not go very perpendicular. Try that again. That's pretty good. Okay. And now, here is my beam of light hitting the glass. And I can actually stretch it. So that's the way the beam of light wants to go. And like you said, so this is glass here, so it's going to slow down. So then the actual direction that the beam of light will take is going to bend toward the perpendicular. So it will actually go this direction. So you can imagine, well, let me say this. So we can measure the angle, the original angle to the perpendicular. Right here was the original angle, and call that original angle my theta. And the actual angle after the light bends is this. We'll call that angle beta. So you can see that mathematically speaking, beta is less than theta. So it's going to deflect toward that perpendicular line. So it will swing this way. Does that make sense? So when it goes into a substance, which it has to slow down, then the light will refract, it will bend toward that perpendicular line. My beautiful work. Just threw that all away. Okay, and then when light speeds up, it bends away from the perpendicular line. So let's go back in here. I should have just kept that. But we're gonna do it this way now. Nope, nope, nope. So now we're gonna come, we've got a light beam that is traveling in the glass. And we are going, ooh, not that. Let's go from the other end. And it's traveling through the glass. You having fun there, Finn?
Morse.
You know he is.
Oh,
Sam.
that's the mouse. Is that your mouse?
Yeah. Sam knows.
It works better with a laser. Okay, so here is, I'm going to draw my perpendicular straight through the straight through here. Come on. No, it's not exactly perpendicular, but it's close. Now my line, we have 2 minutes. Here is my line coming toward the surface. I'm drawing it through just so you see the projection. And then the line is exiting the glass, so it will speed up, right? So it's going from glass to air, so it's going to speed up. So which way is it going to bend this time?
Away.
Away from the perpendicular. So in this case, the refraction is going to come like this. So again, you can see the regular projection, that if you were just projecting it, if it was going to continue in glass, then it would continue at this angle right here. But since it is not, since it goes out of the glass, then it swings away from the black line, which is your perpendicular. So the line swings this way or bends back that direction. Okay, it's a very important thing when you start talking about lenses. This is why they work. So we'll get into talking about that stuff next week. But I guess that's really just the key. And there's some actual other diagrams. You're supposed to do, well, you have the experiment 15.3, and that one's actually kind of a little bit challenging to set up. But if you can do that one, again, I don't remember off the top of my head which one I actually put on the syllabus that you've got to turn in. But if you can do that one is actually, it's pretty interesting, and it's fun to watch or fun to look at. It's just, it may be a little bit difficult to set up. So I don't remember which one I required. I think that might have been one that I said y'all don't have to do, because I think you may not have the tools. If you can do the experiment and you have access to a laser light or like a laser level that projects a vertical line, then that'll actually work better than if you have your mouse is probably not going to work, because if you look at it, it's spreading it out. But if you have access to a laser level, so something that projects a level line, something like this right here, then that will actually work better. So this, I'll do this on the wall behind me here. Let's see if it'll, oh, you know what? The battery must be dead on it. Or I may have just taken the batteries out. Yep, it has no batteries in it because they must have been dead the last time I tried to use it. But in any case, that one will project a laser line on the wall. And so you can use something like that if you have access to it. Otherwise, a laser pointer will work better. If you can do that experiment, then I highly recommend it. You just, if it's not required, then you don't have to do a report on it. But you can certainly do the experiment and see what you can learn from it. That's always a valuable thing to do. Always try to see if you can learn something new.
Daddy, come in our room, because our room is all cleaned up.
I have a visitor here.
Hello, young seers.
This is Cade.
Hi.
Hi, Cade.
Ah, yes, the apprentices.
There are many. Oh my
Oh,
god.
there's more.
They're multiplying.
They're
Hello.
like the amoebas.
Well, you're good
That's
at
a lot
math,
of kids.
That's not even like half of his kids. I think, right? You have
right? No, that's not half. That's about a third of them come June. And this guy, these two, Cade, come here, Cade. This is Colt right here, and this is Cade. These two guys are twins. Can't you tell?
No. Congratulations.
Oh.
You have do you have syrup on your lips or something? Is that yummy? They're 4. There'll be 5 here in about 3 months.
One that isn't smiling
It's a
right now is the
pandemic
monster.
baby.
What's that?
It's a pandemic baby.
Oh, a pandemic. The one in June.
Oh,
Yeah, my sister nicknamed him Baby Shark. So the one that's not born yet.
Baby shark, baby shark,
Please stop. No. No.
Doesn't it start like this?
What? Wait, what were
It
you doing?
starts with suffering.
Yeah, Baby Shark.
baby shark, baby shark, baby shark. Mama shark, mama shark, mama shark, mama shark.
Baby
You can
Shark
say
does
bye.
not deserve to be that popular. It's
That
a
song
terrible
is-
song.
I agree. It's torturous. Goodbye, little seers.
Right now.
Not yet. It's not much of a song. I'll have to say that. I have to agree with that. But I think it's actually pretty funny that it has become so popular.
It deserves to die. It needs to burn in a fire.
I don't know. That
I don't think that a non-material thing can burn, but I could be wrong.
Its
And
reputation
burn the
can burn.
sharks. We'll get rid
Buy
of
it on
all of
vinyl.
them.
Buy it
Pretty
on
much
vinyl
it's-
and then burn it.
it's here to stay. So I don't think there's really much of anything we can do about it other than, acknowledge it. And if it irritates you, then ignore it.
Can't ignore it when it's being blasted into my ears by a certain somebody.
By your classmates. Oh, that's perfect.
I'm gonna have to say that I'm not sorry about that. Because we're not supposed to lie. So
Yeah. It's
We're
your
all sorry for
moment of culture for you there.
That's torture, not culture.
Oh, well, what did you guys grow up listening to, Barney?
No.
Adventures in Odyssey.
Well, there you go. See now?
Oh my gosh.
Jonathan Park.
Adventures in Odyssey. That's a good one. I like that.
Yeah.
I've been listening to it ever since my mom was listening to it whenever she was a kid. So
Yeah.
we've been listening to it.
I grew up to the Backyardigans.
Backyardigans and VeggieTales. Those are mine.
Oh yeah.
Yeah.
And Blue's Clues.
I grew up with none of that.
Anything on
I
KU?
cheated on Rock.
Wildcrats, Curious
I don't remember.
George,
Poor Finn.
Arthur.
Blue's
Finn grew up on
Clues,
dirt.
Dora, Diego, you name it, we watched it.
So
We
I'm just
didn't
saying,
watch Pokemon.
I'm just saying Baby Shark.
I
Baby
watched
Shark is not super complicated. But the little kids love it for whatever reason, and that's to me what makes it funny. And
They love
then
it because we hate it.
there also has been plenty of really lame stuff from back when all of us, the stuff that I watched when I was a kid was arguably pretty dumb too. I mean, I grew up with in the Sesame Street days, and so I mean,
Sesame
you have the whole
Street is a
you have the
blessing,
whole
and you know it.
you have the whole Grover thing. Near, far.
No, it's just far.
Near.
Stay far away.
What?
Sarah the strawberry has snapped officially.
I said it's not near and far. It's just far. Just say far away.
Sarah,
was
Sarah, you could have
quick
had your
thinking.
face cam on this whole time, and you just left it off.
Because of strawberry.
You completely lost me on that one, Sarah. Well, in any case.
Stay far away from people and the coronavirus, so it's not near and far.
Oh,
It's
yeah.
far.
So I should be like near, but not more than 6 feet, or not less than 6 feet.
Oh
Do you
my
like?
God.
Do you like my Grover voice too?
Yes, it's
Yeah.
wonderful.
And then there was Rocky and Bullwinkle, and I can do a killer Bullwinkle voice too.
And Sterling, the reason that I haven't had my video on is because I've been doing this. Been building my pigs a cage. They're not
Yeah.
big. They're little people. Spider-Man, Twix, Coco, Orca, and Oreo's under the bed because he keeps trying to leave his house. He tries to escape and has been successful. Woke up one
Oreo?
morning, him like under my sister's bed. So
I'm confused. Also, Claire's little brother walked in through the door as soon as she turned on a virtual background, which made his face completely white, and it scared the crap out of me. He was like this totally white, blank, tiny Slenderman with black clothes on, and he just it was terrifying.
He's been trying to embarrass me the whole time by waving his arms in the camera.
I know, I saw that. It was hilarious.
Incognito.
Brady,
Yeah, I saw him too.
Brady, you gotta get the hoodie, the science hoodie.
Yeah.
Bring Tate in here. He's amazing.
Tate? I agree, he is amazing.
Hey.
Tate, you've been summoned by the Council of People.
Physical science.
Summoned
The
for
council
examination.
inside your faith.
The Council of Councilmen.
Hi, Tate.
What's
Council of
up?
water sheep.
Say
I
water
can't.
sheep.
hi.
Hi.
What's up?
Tate's like, now that I'm supposed to be here, I don't want to be here.
He's like, I'm gonna leave now.
Nope,
We
he
can
ain't
still
leaving.
see you.
Fine.
Yeah, but he can't hear us. Yeah,
Brady!
he's still spying he's around the corner
Yeah,
spying.
Come on.
Tate's,
Wait,
Tate's in the
Wait,
doorway.
hang on. Sam,
Sam, you're
you're a
scaring
man
me.
of kosher. But Ben is terrifying me. He's in
Hey, okay.
Australia.
Oh, I get
He-
that joke. I get that. That's pretty good. Good job, Sterling.
I don't know how its blood isn't running to his head. I'd be getting
Yeah,
super
Ben-
dizzy by now. Oh,
yeah,
now
Ben's
sideways.
just flipping his. He's just spinning.
Wait, Ben is spinning on your screen?
He
What?
turned sideways. All right. Well, does anybody have any other questions? science stuff for
Reading
me?
is fun.
I have something
Okay.
scientific.
Well, look for, sorry it's taken me so long, but look for your quarterly tests this weekend or by Monday. I'll try to get those emailed out. I'll probably have them done. Check the STEM Science site for grades. If I get them done, I'll post all the grades up. I'll post all your scores there, so you can at least look at your score. And then I'll be sending you a little a grading little tabulation deal that will tell you which problems you got right and what. If you got partial credit, and some notes with it as needed. So, all right. But anyway, this has been fun, and I guess I'll see you all next week. Feel free to give me a text message or a call or whatever if you have any questions. Wait, what is going on with? Oh, Sterling has actually got everybody else's pictures going on his screen.
I can't see it. Sterling, talk so I can see your screen. What the heck?
That's pretty weird.
Why?
Unlimited power.
How
You
did
can
you
see
do
it on the
that?
right just spinning.
All right, I think that's where I'm just gonna say bye, crazy people.
Yeah.
See you next week.
One
Okay.
more thing, though. All right, so we're allowed to leave now, right?
Yes.
That
You're
is
One more
dismissed.
thing, though. Pizza goes in the oven.
And microwaves emit nuclear radiation. It's fact.
Ben, you failed the class. You said the M word.
Microwaves are
You
dangerous.
did. Finn said
Toaster
that-
ovens
You get flunked.
are supreme. They're primo. Toaster
Finn
ovens are great.
immediately loses all his bonus points.
Yep.
Negative
Did he
1
have
million
any?
bonus points. Ooh.
Did
Not
he
that I
have any?
had much after the 12 saga. Of me answering every question with 12. That was fun.
I don't remember that one, but it's a good thing. I short memory on minor things like that.
Oh my gosh, I can tear the fabrics of reality. Look at that, that's sick.
Don't cover Stanley's face.
I
You
won't.
know
I'm
that's
sorry.
not really that as cool as a full light up mouse, you know, or keyboard,
That's true.
This blinding.
or headset, because I got two. I don't know why I have two, but I have two.
Stanley. Wait, where's Stanley?
Who else has been drinking
Don't
coffee
crush-
this whole time?
I haven't
I
been
actually
drinking
haven't.
coffee this morning,
I
but
hate coffee. Coffee's disgusting.
I'm going to
Coffee's
drink
bad for
coffee.
you. It stunts your growth.
I don't care.
I love
It's
coffee.
good.
I'm very tired. I gotta stay up all night.
Usually when I wake up, I'm cold, and coffee makes me warm up.
Tea.
Coffee is disgusting.
Coffee is incredible.
Drink tea. Tea is good.
It depends on what
You
kind
need
of
a
tea.
bowl of cereal and some popcorn, and you'll be fine.
All
Popcorn?
right, y'all.
Popcorn.
We got to jump out of here because the biology people's going to be jumping in. So
All right,
we'll see you.
signing off.